Have you heard about the discovery of the century, the planet Proxima B in the Alpha Centauri constellation? Did you know that it's called Earth's twin? Watch the video until the end, and you'll find out why this distant planet got its nickname and why scientists aren't ruling out the possibility of searching for life in other galaxies. In August 2016, astronomers announced an amazing discovery. Next to the closest star to us, Proxima Centauri, an exoplanet has been discovered, named Proxima Centauri b. This discovery sparks huge interest all over the world, since Proxima is just 4.22 light-years away from our Sun, making it our closest cosmic neighbor. Although Proxima Centauri looks like a single star when observed from Earth, it's actually part of a triple star system along with two other bright stars, Alpha Centauri A and B. These two suns are a bit bigger and brighter than our own, and their orbit is about 40 to 47 astronomical units apart, completing a full cycle every 80 Earth years. But Proxima is a whole different story. This red dwarf is significantly smaller and dimmer than our Sun, being about 7 times smaller and 33 times weaker. Because of this, the habitable zone around it, the area where conditions might be ripe for life due to the presence of liquid water, is much closer to the star than it is with our Sun. If our habitable zone stretches from 0.38 to 10 astronomical units, then Proxima's zone is just 4 to 0.08 astronomical units away from the star. The discovery of Proxima Centauri b happened thanks to years of observations by scientists at the European Southern Observatory, ESO. The project was codenamed Pale Red Dot, highlighting the dimness and remoteness of the star. Despite Proxima's relative closeness to Centauri, it remains a challenging object to study due to its low brightness. So, in 2016, a group of researchers from the European Southern Observatory announced the discovery of Proxima b, the first exoplanet found near Proxima Centauri, the closest cosmic object to us after the Sun. The planet has drawn attention due to its unusual position relative to the star, which allows water to remain in a liquid state, as well as its mass, which is only 30% greater than that of Earth. While Proxima b shows promising similarities to Earth and is located at a surprisingly close distance of 4.22 light-years, there are fundamental differences between the two worlds. These features might suggest that our hopes of finding a second home for humanity could be premature, and instead of the paradise we expect, we might run into something completely different. So, despite the outward appeal of Proxima b, the reality could be less rosy. However, studying this planet is an important step forward in understanding the limits of habitable worlds and the prospects of searching for life beyond our solar system. It seems that this world could potentially become a new home for life. Nevertheless, studying this planet is an important step forward in understanding the limits of habitable worlds and the prospects of searching for life beyond our solar system. It seems like this world could become a new home for life. However, before jumping to conclusions, it's worth considering some important details. What's wrong with the planet? Let's figure it out. Proxima Centauri is a red dwarf star that is significantly smaller, lighter, and dimmer than our Sun. As a result, to get enough heat, the planet has to be much closer to its star. Such proximity leads to powerful tidal effects. In particular, Proxima b experiences such strong tidal forces that it becomes locked in relation to its star. This means that one hemisphere of the planet is always facing the star, while the other is eternally turned away. Its close proximity to the star also results in a short orbital period for Proxima b, lasting just 11 Earth days. This means that one hemisphere of the planet is always facing the star, while the other is eternally turned in the opposite direction. The close proximity to the star also results in a short orbital period for Proxima b, just 11 Earth days. Just 11 Earth days. The effect of the planet's rotation being slowed down, or it always faces the star with one side, means that the familiar change of seasons is absent here. The seasons depend solely on the shape of the orbit. If it's close to a perfect circle, the seasonal temperature fluctuations will be minimal or even non-existent. The seasons here depend solely on the shape of the orbit. If it's close to a perfect circle, seasonal temperature fluctuations will be minimal or even non-existent. The hemisphere that always faces the star is likely to be scorching hot. It is continuously exposed to sunlight with no chance to cool down. On the other hand, the area in constant shadow will be plunged into eternal night, remaining cold and dark, although the night sky that promises to be stunning. The boundary between these two areas, a sort of ring around the planet, will witness constant sunrises and sunsets, creating conditions that are as close to Earth-like as possible. Red dwarf stars like Proxima Centauri are more active and unpredictable than stars like the Sun. They regularly produce powerful flares capable of destroying any life on the planet's surface. The Earth's magnetic field protects our planet from emissions, but Proxima B likely lacks a protective field since it doesn't rotate. Although Proxima B is closer to its star than Earth, Proxima Centauri is much cooler and weaker, emitting little ultraviolet rays. It emits little blue light. Although Proxima B is much closer to its star than Earth is to the Sun, Proxima Centauri is noticeably cooler and fainter, emitting virtually no ultraviolet light. Consequently, it emits almost no blue light, the same light that plants on Earth need for photosynthesis. Life on this planet will have to find alternative ways to obtain energy. On our planet, thanks to its rotation and the presence of climate zones, energy is distributed unevenly. During the day, Earth receives more solar energy, and at night, it releases that energy back into space. This creates conditions for the formation of longitudinal air currents, which we call winds. On planets like Proxima B, where one side is always facing the star and the other is turned towards space, the principles of energy distribution are fundamentally different. Winds will blow from the hot hemisphere to the cold one, carrying heat and moisture across the ring zone. For an observer in this area, it will seem like the wind is coming straight from the Sun, which, in a way, is true. Proxima Centauri is smaller and dimmer than the Sun, having only 12% of its mass, 14% of its radius, 0.17% of its power output, and 0.005% of its visible luminosity, 17% total power output, 0.17%, and the visible luminosity is just 0.005%. However, because Proxima B is so close to its star, it will appear 10 times larger in the sky than the Sun does from Earth. The main portion of the star's energy is in the infrared range. So, by closing your eyes and soaking up the warmth, you'll feel about 2/3 of the heat you get from the Sun's rays, but without the risk of getting burned since there's no ultraviolet radiation. The surface temperature of Proxima Centauri is significantly lower than that of the Sun. Only 2,700 degrees Celsius instead of 5,400. Any living organisms on Proxima B will primarily perceive the long wavelength red spectrum. Unlike most bright stars, including Alpha Centauri A and B, as well as our Sun, which are hot and emit more blue light, the night sky of Proxima B will be filled with blue color. On the other hand, in the Earth's sky, most stars appear white because their temperatures are similar to that of our Sun. On the other hand, in the Earth's sky, most stars appear white because their temperatures are similar to that of our Sun. The Breakthrough Starshot initiative, launched in 2016, immediately caught attention with its ambitious plan and impressive lineup of participants. Among them are notable figures like Stephen Hawking, Mark Zuckerberg, and Yuri Milner, a well-known Russian entrepreneur and venture capitalist. The project's goal is truly grand, to send an entire armada of tiny spacecraft to Proxima Centauri B in the coming decades. These tiny probes, called starships, are planned to be delivered to low Earth orbit and then released into open space, no matter how many light-years separate us from Proxima Centauri B. It is assumed that each such microcircuit will weigh no more than 1 gram and 1,000 such devices will be launched simultaneously. Starships reach Proxima Centauri. Some may fail, but a few will send data back. Using solar sails, they'll transmit data to Earth, letting us see Proxima Centauri B in over 4 years with 20-megapixel resolution. Naturally, some of the devices might fail or go off course, but at least a few of them will reach the target and send back valuable data. Using solar sails as antennas, they will send information back to Earth, and in just over 4 years we will be able to see Proxima Centauri B and its surroundings at 20-megapixel resolution. If everything goes according to plan, of course. At the end of 2020, astronomers working at observatories detected a signal that was different from normal natural phenomena among more than 4 million already studied data points. This signal raised suspicions, and further analysis confirmed the worst fears. In the fall of 2021, it became clear that the unusual wave pattern was caused by intermodulation, a complex interaction of several radio signals coming from ground systems and satellites, although the exact sources remain unknown. In addition, doubts about the habitability of Proxima Centauri are raised by the activity of the star itself. This restless red dwarf star periodically flares up, releasing ultraviolet and X-ray radiation that could sterilize the planet's surface. Protection from such effects could be provided by a strong magnetic field, but whether Proxima B has one remains in question. Some studies suggest that Proxima Centauri B might contain a significant amount of water, possibly up to half of its mass. According to some scientists, the entire planet is covered by an ocean that's up to 200 kilometers deep. If there is life on it, it would probably resemble intelligent octopuses like the characters from the Soviet film Through Thorns to the Stars, rather than humanoids from the novels of Chinese sci-fi writers. To finally uncover the truth, we'll have to wait for the arrival of the interstellar fleet of starships, and for now, this closest potentially habitable planet remains out of reach. As of 2024, we can confidently say that the Breakthrough Starship project will be realized. Despite the passing of Stephen Hawking in 2018, work is in full swing, and the launch of the starships is scheduled for the mid-2030s. Over the years of development, scientists have had to overcome many challenges, mainly related to the creation of the probes themselves. Work is continuing at full speed, and the launch of starships is planned for the mid-2030s. Over the years of development, scientists had to overcome many difficulties, mainly related to the creation of the probes themselves. Until now, solar sails have remained a product of experimental engineering creativity. But the international team behind the Breakthrough Starship project has found a way to adapt this technology for mass production. Scientists turned to an artificial intelligence method known as neural topology optimization. Designing a perfect pattern for millions of holes is nearly impossible for humans. AI and computational physics algorithms help solve this. Researchers created a design with bean-shaped holes, each 200 nanometers thick. Engineers used this to produce a 35 square centimeter sail sample, weighing just a few micrograms. As a result, the researchers created a nearly finished design, a mesh with holes shaped like little beans, each about 200 nanometers thick. Using this design, engineers were able to create a sample of the future sail measuring 35 square centimeters, weighing just a few micrograms, a millionth of a gram. So, the idea of small ships powered by solar sails could soon become a reality. At the end of 2021, the largest and most powerful space telescope ever built by humans was launched from Earth. The James Webb Telescope took 25 years to develop, and the goal of this grand project was to explore the depths of the universe in search of signs of life. Scientists from NASA, the European Space Agency, and the Canadian Space Agency worked on this device. The cost of building the telescope was $10 billion. Webb's primary mission is to study distant objects in the universe, such as the first galaxies. Since the light from these objects is shifted into the red part of the spectrum, the telescope is equipped with technology to work in the infrared range. The device is equipped with a near-infrared camera that can capture objects previously invisible to the human eye and cover an area of the sky 15 times larger than the previous generation's camera, the Hubble telescope. At the end of October 2024, NASA unveiled a new image of the ghostly galaxy M74 NGC 628, captured by the James Webb Space Telescope. This image combines data obtained using the MIRI and NIRCam instruments, allowing the FIS team, feedback in emerging extragalactic star clusters, to delve deeper into the so-called stellar nurseries in the galaxy. These nurseries are areas of space rich in gas and molecular clouds, where new stars and planets are formed. The main goal of the FIS project is to study the impact of star energy on the surrounding environment to better understand the processes of star formation beyond our galaxy. Looking at the latest achievements of cosmologists, we can confidently say that Proxima Centauri B is just the first of many similar worlds that we might discover soon. Hey friends, I also have an interesting offer for you. You have a unique opportunity to become part of our team. If you have video editing skills, can voice over videos in Russian, English, and other languages, or write interesting scripts, we'd love to work with you. Just message our Telegram bot. We'd be happy to work with you. Message our Telegram bot. The link is in the description. And that's all for today. Good luck and see you soon.